off and running. I just want to cover a couple of, I suppose, basics of binomial distribution exam questions. We'll study the binomial distribution quite a lot further a bit later in the course, but for now what we want to be really familiar with is how do you use the calculator for this? What does the terminology actually mean? And how do you do the different types of calculations that you've got? So here we have a probability of Harry being late for school is 0.1 over a term of, oh, hang on, that wasn't the question I was going to start with. There we go. This was the question I was going to start with. So we have here a discrete random variable, x, which is distributed with a binomial distribution, 15 trials, and a probability of success 0.35. We want to find a, b, and c, those different things. Now you'll notice that if you look at the questions a, b, and c, we have x equals something, we have x is less than something, and we have x is less than or equal to something. And there are three completely separate techniques that we're going to use to do those. So what does this even mean, all right? A discrete random variable is the outcome of an experiment. The fact that it's discrete means that it can only take whole number values. So if you have an experiment, say for example, you throw a dice and you want to observe the number of threes that you get, then it's either a 3 or it's not a 3. All right, it can't be a 3.125, it can't be a 4.325, it'll be 1, 2, 3, 4, 5, or 6 whole numbers. And that idea that it can be a 3 or it can be not a 3 is what leads us into this idea of something being binomial. The bi literally standing for 2. Okay, so it's either something or it's something else, and it has to be whole number values. So this outcome of the experiment, we're saying, does follow this binomial distribution. Okay, so you have a it is or it isn't situation. This 15 means there have been 15 trials. So I can make a quick note of that just in case we need it. We don't need it for this question, but it's good for the understanding. There are 15 trials, and the probability of success in each trial is 0.35, right? Now, if we know that the probability of success is 0.35, then the probability of fail, which is the opposite of success, not success, is 0.65, because these two probabilities must add up to 1. So I can get all this information just out of this little piece of writing. Okay, we have an experiment, 15 trials, we have a probability of success, that means there's a probability of failure. So now we get into the calculation itself. What's the probability that x equals 5? Okay. So we're saying here is what's the probability, that's not part B, that the number of successes is equal to 5. That's what we're interested in, 5 successes, all right? Now, if there are 15 trials, I'm just going to break this apart a little bit. That means we're looking for 5 successes, but that means that there will be 10 fails, all right, because we are still doing the 15 trials. Now, if I was to ask you the probability of working out 5 successes and 10 fails, chances are you would say something like 0.35 to the power of 5 multiplied by 0.65 to the power of 10, okay, the fail probability here, the success probability there. Now, this would be right, okay, so far, because it's an and probability, all right? What's the probability of success and success and success and success and success and fail and fail and fail and fail all the way up to the 10 fails? Okay, so we're using that and probability. But what this calculation actually does, just this part here, is it gives you the probability that you have the first 5 trials are successes and then the last 10 trials are fails. Now, what happens if you have a success and then a fail and then 4 more successes and then 9 more fails? That's actually a different situation. So that would be 0.35 multiplied by 0.65 multiplied by 0.35 to the 4. So 1 success, 1 fail, another 4 successes, and then another 9 failures. And you might think, Well, yeah, that's just the same calculation. 0.35 times 0.35 to the 4 is 0.35 to the 5. And you'd be right. However, this is a different situation. This is the first 5 successes were, first 5 trials were success. This is the first one was success, the next one wasn't, then the next 4 were. And we could go on like that. And we could say, what if the first 2 were successes? And then the third one wasn't. And then the next 3 were successes. And then the next 9 were not. All right? So we'd have that situation going on. So we've got to kind of think about how many different ways are there of getting 5 successes out of 15 trials. And the way that we do it, using the calculator anyway, is using the NCR function. All right. So NCR is if you have a number of trials and you're looking for a number of successes, how many different ways are there of working that out? And for this calculation, it's 15 trials, C 5 successes. Now this literally means out of 15, choose 5. How many different ways are there of doing that? And the great thing is your calculator does all the heavy lifting here. So we've got this 5 successes and 10 failures, and then we've added in this. This will tell us how many different ways there are of doing that. So what we've got to do now, use the calculator. So we'll go 15, shift, divide, C5, multiplied by 0.35 to the power of 5, multiplied by 0.65 power of 10. Let that go, and we get 0.2123, 4 decimal places, which is what I always leave my probabilities to. We're done. So then for part B, we're being asked a slightly different question. What's the probability that you have less than 4 successes? Now, you can think of this as, that's like saying the probability of 0 successes plus the probability of 1 success plus the probability of 2 successes plus the probability of 3 successes, but not 4, because it has to be less than 4. So one way that you could do this is you could actually do this calculation here for 0, 1, 2, and 3. All right? But it would take a long time. It would take a long time. So instead, what we do is we use a function on our calculator called the binomial cumulative distribution. And that works this out for us. But only when we have this written in the right way. So we have to say that the probability that x is less than 4 is the same as the probability that x is less than or equal to 3. Because our calculator only works with probability x is less than or equal to something. Now I hope you can see how that works. So if I have my numbers on my number line, 2, 3, 4, 5, and I know I'm interested in all of the numbers less than 4, then those are the numbers that I'm interested in. So I must rewrite the question as the probability of x less than or equal to 3. Now once I've done that, we'll go menu on our calculators, we'll go 7. None of the options up here are what we're interested in at the moment, so we'll scroll down till we see binomial CD. Once we're on binomial CD, we choose variable, and then we can put in 3 pieces of information. Our x value, which is the number that we're testing less than or equal to, so in our case 3. Our n value, which is the number of trials, which is 15. And our p value, which is the probability here, which is 0.35. Pressing equals will lock those in. Pressing equals again will give you the probability. And again, 4 decimal places I'm using for my probabilities. So that's a quicker way than adding up all of these. But in order to use that quicker way, you must write your calculation as less than or equal to something. So we'll move on to part C. What's the probability that x is less than or equal to 10? Okay, so a quick check. This already says less than or equal to. so I can go straight to the calculator and type in what I need. Now, if I press AC from this answer here, I go back to this screen and I can just change any of the values that I want to. So our X value there is not going to be 3 anymore because we're testing X is less than or equal to 10. 15 trials, probability of success 0.35. I've pressed equals once to lock in the 10. I'll press equals again and it'll give me my probability. So we've got 0.9972, again correct to 4 decimal places. Quite a high probability. So that's the basics then of using the calculator to find your answers for a binomial distribution. And I hope it makes sense that why we need this 15C5 function. We only need it when we're doing an equal to calculation, all right? Anything else with an inequality, we're going to use the calculator. So let's have a look at the second one. This was the one that was after the second one. The probability of Harry being late for school is 0.1. Over a term of 30 days, find the probability that Harry is late, blah, blah, blah. The first thing you've got to do in a question like this, and sometimes you're actually awarded a mark for doing this part, sometimes not, but sometimes you really are. You've got to write down what the distribution is. And if the question says, write down the distribution, or what is the distribution, this is what it's aiming for. You're going to translate this sentence here. Right, this part here, you're going to translate it into maths. So I'm going to nominate X as my discrete random variable. X is going to be binomially distributed because Harry being late, well, Harry will either be late or Harry will not be late. Right? You can see that there's only 2 different outcomes for this. We need a number of trials, right, N, and we need a probability of success, P. So in my distribution, X is B, 30 days is my number of trials, and the probability of being late, which in our experiment is a success, in inverted commas, is 0.1. All right, so that's turned this bit into a little bit of maths, and now I'm back to exactly what we did last time. So what's the probability that Harry is late exactly 1 time? We're looking for the probability that X equals 1. Now remember, there are lots of different combinations we can use for this. Harry could be late the first time and then early the next 29 times. Harry could be early the first time, late the second time, and then early the next 28 times. So we have to factor in exactly how many different ways there are of doing this. And that's our NCR calculation. So we're going to use 30 trials, choose 1 lateness. We're going to multiply that by the probability of lateness to the power of 1, because it's the number of times we want Harry to be late, multiplied by the probability of not being late, 0.9, and that's going to be to the power of 29, because 1 late means 29 not lates. Type it right into the calculator, 30C1 multiplied by 0.1, and I'll put in these powers. 30C1 is 30. Okay, you'll get to know that once you actually get a bit more of a feel for it. 0.1 to the 1 is just 0.1, but you can see how I'm typing everything in from the calculation. It gives me less to worry about and less to think about. So then I've got my 0.9 to the power of 20. And here's my probability, 0.1413, correct, 4 decimal places. So now we're going to go on to question B. And again, we've got to interpret this language. It says more than 4 times. So that's the probability that X is greater than 4. Now, as I said previously, your calculator only works when we do the menu 7 option. It only works with less than or equal to. Let's just go to that now. Menu 7. Scroll down. Binomial CD is option 1. 2, we have to use variable. And then we put in our values. But this has to be a less than or equal to value. So this is what I do every single time, right? I'm going to look at this number 4. I'm going to choose a couple numbers either side. I'll say, and I'm going to write a number line 2, 3, 4, 5, 6. Okay, this is what I do every time. If X is going to be greater than 4, the first number that it's going to be is 5, right? So this is my x is greater than 4. That's the probability from 5 all the way up to 30. Now my calculator doesn't work that out, right? That's not what it does. So instead, I can work out everything on the left, which is everything where x is less than or equal to 4. Okay, now I hope you can see that. X greater than 4 starts at 5, so everything to the left is going to be x less than or equal to 4. Now everything to the left and everything to the right, when we add those probabilities together, we're going to get 1. So the probability that x is greater than 4 is actually 1 minus the probability that x is less than or equal to 4. All right? This side plus this side equals 1. So if we take the left-hand side away from 1, we are left with the right-hand side. So let's see how we use our calculator to do that. X, we're going to use 4. N is 30. P is 0.1. Lock them in, get the probability. 0.8245. Now I've rounded that, and for the sake of accuracy, we're going to want to keep this unrounded value in our calculators. And here's the way that I do it, because the probability here, as far as I'm aware, does not simply store to the answer function. All right, because we're going to change the menu option back to a calculator, we're going to need to store this number elsewhere. Now on the class whiz, you can simply, you press STO, and then you'll notice this little red A. If you just press that button, you don't need to press alpha at this stage, just press that button, it will tell you it's been stored to A. Then if we click menu 1, which is our calculator screen, I can say 1 minus, now I want the answer that's been stored in A. This time I have to use the alpha button, so I'll do alpha A. And that gives me my unrounded version. Chances are it would have rounded to the same thing anyway, but it's always good practice. 755 to 4 decimal places. All right, so that's our probability of x being greater than 4. Now, finally, less than 3. So less than 3 is the probability that x is less than 3. Again, I'm going to draw a little number line. I'm going to write it out. 1, 2, 3, 4, 5. Again, just a couple of numbers either side of the number of interest. X is less than 3 is anything 2 and below. So if I wanted to actually work that out on the calculator, I'm going to do the probability that x is less than or equal to 2. And then we type it in. So menu 7 again. Someone's about to come in for their lesson, so I'm going to apologize to them. So 1 and then 2 for variable. We got 2. And the number of trials, as we said before, was 30. And our probability was 0.1. We'll lock those in. We'll get our answer. 0.4114, correct to 4 decimal places. And that's it. That's how you use your calculator in a binomial distribution exam question. That's how you think about turning your greater thans into your less than or equal tos. I always use the number line, and I encourage every student to do that because it just makes sense. And yeah, that's that. So what I think I'll do next week is I'll try and find a more involved and wordy exam question. Again, we'll stick with the binomial distribution for now, and I'll talk you through that one as well. All right.